Okay, the original post for this problem had a whole bunch of problems, A through K. This video answer is just going to look at K. Y equals the cosine of x raised to the natural log of x power. And of course, in that situation, x has to be greater than 0 because you cannot take the natural log of a number that's not positive. Okay, so this is the graph, this red graph. It's the graph of that function. These green dashed lines are the graph of the derivative. And one of those graphs is just f prime of x on Desmos. And here's the answer that we're going to end up with by actually finding the derivative manually. This black line is a tangent line at a given point. If you visit this Desmos graph, you can actually slide this point to other locations on the graph to see the tangent line. So let's see the technique for ending up with this answer right here. So there's the original function again. The idea is when you have a function of x raised to a function of x, you want to take the natural log of both sides in order to move this exponent down front using power property of logarithms. So that's what happened in step 2 here. And now we can take the derivative implicitly using the product rule on the right. So the derivative of ln of y is 1 over y times y prime. And what we'll end up doing is multiplying both sides by y to isolate the y prime. So product rule, here's the first function times the derivative of the second function. Well, the derivative of the natural log of anything is 1 over the anything. And then we have to apply the chain rule. So the derivative of cosine is negative sine of x. Plus the second function, natural log of the cosine of x, times the derivative of the first, 1 over x. So here I've multiplied both sides by y. I simplified negative sine x over cosine to tangent, and I reordered the terms so the term with the minus sign came second. And here I replaced y with cosine of x to the ln of x power. So this is your formula for the derivative right there. Okay, there you go. Hope that helped. And by the way, if I go back to board 1, part J is done in a very similar fashion. Take the natural log of both sides and move the cosine of x down front. Well, this is supposed to be an L, I'm sure. And use the product rule. By the way, HI is a pretty complicated expression. X cubed minus 3 in the numerator times the square root of x squared plus 1 in the numerator, all over x plus 5 to the 2/3 times cosine squared of x. If that's what y equals, good luck using the quotient rule and the product rule, the chain rule. Figure it's really messy. What you want to do is use logarithmic differentiation. Once again, taking the natural log of both sides. But the idea is if I put an ln out front here for this whole thing, I've got the log of a quotient, which means I can take the natural log of the numerator minus the natural log of the denominator. Then I can apply the power rule. So it looks something like this. Natural log of x cubed minus 3. Write this as x squared plus 1 to the 1/2. So I can say plus 1/2 natural log of x squared plus 1. And then minus 2/3 natural log of x plus 5. These are all properties of logarithms, minus 2 times the natural log of the cosine of x. And then you can take the derivative term by term using the fact that the derivative of natural log is 1 over x, or 1 over u times the derivative of u with respect to x. Okay, there you go. Hope that helped. If you have any questions, post a comment.